Yeah, y'all, so like I said, we're going to start with 9.1. And this deals with what we call the composition of functions. All right, so what do we mean by composition of functions? So y'all, I'm going to sort of write out a little definition on this. So the composition of functions is when one of our functions is used as the variable replacement for another function. So you know what I mean? They're going to give us two functions. And depending on the terminology, which I'll give you in a second, we take one of the functions and we put it into the variables of the other function, okay? So instead of us just putting in a number or another letter, we're going to be putting a whole function into it, okay? So there's two types of notation we'll see. So first of all, F compose G of X. Now, that little symbol there, that's not an O or a zero. It almost looks like a degree symbol. And this is what we call the composition operator. Okay. So what this really means when you see F compose G of X, that's really F of G of X. So what that means is we take this G of X function and everywhere the F function has a variable, we replace it with that whole G of X function. Okay. So this means the G of X function is put into each X for the F of X function. And you'll see this kind of stuff in sciences. When you got a formula, sometimes you have to know what another formula equals before you can work on a different formula, okay? Like if you're looking for force, well, to find force, you need to know what the acceleration is. So acceleration would have its own formula, okay? So the second way we reverse this, and we have G compose F of X. So what this means, this is really G of F of X. So what we'll do now, we'll take the F of X function and put it into each of the X's for the G function. So the F of X function is put into each X for the G of X function. So this is one time in math where stuff sort of is reverse of what it looks like. So F of X into the G here. So you're sort of going from the right to the left. And then the same thing here, we would put the G of X into the F, okay? Now, if they give us numbers to put into these functions, here's what we do. So if numbers are given, so say we had something like F compose G of A. So we're just going to let A represent any number. But if they gave me a number here, the first thing I would do, we would find G of A. We would figure out what this G of A equaled. Now, once we found what G of A equals, we put that value into the F function. So put that value into our F of X. And then at that point, evaluate. So if they give me a number to put in, I'm going to get a single number out of this when we're done, okay? And y'all, of course, G of F of A, G compose F of A. Same thing, except you're going for the F first. Okay, so in this case, we would find F of A first. We would put that value into our G of X. And then evaluate and see what we get. So really, these are a lot easier when you got numbers given. So the homework will start out with 3 problems doing numbers. And then we will get into when they don't give us numbers, what we do. So if they don't give us numbers on these kind of problems, all we can really do is simplify them. We really won't get an answer out of them, okay? So y'all, let's play with a few of these. So this first one will be like your homework number 1. They want to let f of x equal negative 3x minus 1, or g of x is going to equal x squared minus 2. They want us to find f compose g of 7. Okay. So if I was going to write this with the lingo we used up here, f compose g of 7 is really f of g of 7. So what this means is we're going to put the 7 into the g. So we're going to find g of 7, just like we said here when we got this. We're going to find g of that number. So first, we're going to find g of 7. So y'all, to find g of 7, we're going to put a 7 in for that x on the g function. So that'll give us a 7 squared minus 2. All right, so we would work that. Following order of operations. 7 squared is what, 49? Minus 2. And then 49 minus 2 is 47. So since g of 7 equals 47, we now going to put that value into our f equation. So my f equation was negative 3x minus 1. I'll replace that x with the 47. So my second step, since I'm putting a 47 in for the x, we're going to find f of 47. Hey, y'all, so here we go. our F equation, negative 3x minus 1, we'll bring down to negative 3. Put the 47 in for our x, and then minus 1. All right, so once we evaluate this, we'll have our final answer. So y'all, let's see, negative 3 times 47, I think we get what, a negative 141 minus 1. And then negative 141 minus 1 gives us a final answer of a negative 142. So y'all, the answer we would put in MathLab is the negative 142, okay? So y'all, look, they're not too bad with numbers, okay? So I'll let y'all catch up real quick and then we'll turn the page. Y'all got any questions on this yet? Yeah, like I said, they're not too bad with numbers. Those questions will come when we do it with the variables only, probably. Hey, also, let's see what they want here. They're given f of x equals 2x plus 4, g of x equals x squared minus 3x minus 5. On this one, we're going to find g compose f of 7. So it looks like 7 is my lucky number for today, huh? Alrighty, y'all. So guess what? Remember, this is like g of f of 7. So sometimes writing it like this lingo sort of makes you realize, hey, I got to find f of 7 first. Once I find f of 7, we can put that into our g, okay? So remember, this one's backward because you got the g compose f. So first, I'm going to find f of 7. Well, y'all, the f function is 2x plus 4, so I'm going to put a 7 in for the x. So I got 2 times 7 plus 4. All right, we're going to do our order of operations. 2 times 7 is what, 14? Plus my 4. And y'all, 14 plus 4 gives us 18. So we know what f of 7 is. So remember, our second step is to find, well, we found f, so that's going to go into the g now. So we're going to find g of this 18. Okay? So it's a two-step process. Find the first value, and then that value is going in the second equation. And ooh, y'all look at that. I got a 18 squared minus 3 times 18, and then minus 5. Now, y'all, ooh, that 18 is a big number to square. So if you got to, hit it on the calculator. But 18 times 18 is 324. That'll be minus my 3 times 18, which is 54. And then minus my 5. Now, y'all, so now it looks like all we got to do is take that 324, subtract 54, and then subtract 5 more. Doing all of that, I get a final answer of 265. Okay. All right, one more of those, and then they do, so they do 3 with numbers, and then they'll do 3 with just variables, okay? So y'all, the last one here, we're going to let f of x equal 3x plus 4. G of x is going to equal x to the third. We're going to find f composed g of a -4. So, what is the first thing that we're going to find? Are we going to find f of -4 or will we find g of -4? And y'all can chat me that answer. All right, y'all, what am I getting? G of -4? Perfect. Because remember, this is like f of g of -4. So good job. We're going to find g of -4. So y'all, we're going to take our g equation, put in that -4. So we have -4 to the third power. All right, y'all, so what's that going to give us? A -4 to the third power. And y'all, let me show y'all, if you do got the calculators, how to figure out what this is going to equal. So I'm actually going to share the calculator screen. And Gatan got on there. Yeah, you're right on that one. Good job. So it definitely will be a -64. But y'all, you can punch in your -4, this upside down V for the exponents, and then punch in your 3. At that point, just hit enter, and we get our -64. All right, so good job on that. So we got -64. So that means our second step, this -64 can now go into our f equation, and we're going to find f of -64. Okay, y'all, so let's see. We got 3 times our -64 plus 4. All right, y'all, punch that up, what y'all get, because let me see. Looks like -188. Looks good to me. And that would be our final answer, okay? All righty, so before I do the last 3 problems dealing with the composition, I've got to show y'all a little bit about a new way to write a domain. Because we've been writing a domain with the fancy parentheses and the X with the bar. And then we said X is a real number and X cannot equal whatever. Well, we get tired of writing all that every time we answer a problem for a domain. So we're going to learn about what we call interval notation. So this is interval notation. And this is for our domains. So the other way we was writing those domains with the X and the bar and all that, we call that set builder notation. So this is a lot easier once you learn this, okay? So the first thing, in interval notation, all real numbers is represented by, now, let me ask y'all this. Think about this. All real numbers. If I go to the left of the 0, and I'm heading into negative direction. And I keep heading into negative direction. And I keep heading into negative direction. What do we say we are heading off towards? Definitely infinity. Now, since we're going into negative direction, Jackson, that's actually going to be a negative infinity. Now, think about going the other way in the positive direction. If we keep going into positive numbers and through the positive numbers, through the positive numbers, we're headed off towards positive infinity. So, good job. So y'all look at this. To represent all real numbers now, we can say negative infinity to positive infinity. That means we're covering every single possible real number that there is. But what about numbers we got to kick out of our domain? So here's where we do what we use a union for in math. So to exclude numbers, we use the union. And y'all, that union really means and. So the union is a U shape. It means and in math. So we use the union. So to exclude numbers, we use the union and parentheses. So let me show you an example. So for example, to exclude any number A, so say this A can be a 1, 2, 3, -5, it don't matter. But to exclude that number from the domain, we have, now remember, they're all going to start over here at negative infinity. But now I'm going to kick this number A out of my domain. So I'm going to go from negative infinity to the A, and I'm going to use curvy parentheses. Y'all, in math, when you use curvy parentheses around a number, that means that it does not equal that number. Okay? If I wanted it to equal that number, I would use brackets. Okay? Now, infinity, since it's not an ending point, always has to use curves because you can't stop at infinity because it's no stopping point, okay? But around numbers, when I use parentheses, that means it's excluding that number. So now um, comes the union. So we put the union down and then start our second set of parentheses. And we go from the other side of that number. So we go from the A until we hit positive infinity. So this is how you kick out a number. I'm going from negative infinity almost to A, but I can't equal A, remember, because I got curvy parentheses. So I can almost get to the A on the left side. And then right after A on the right side, remember, I can't equal A either here because of the curves. So right on the other side of A, I can go all the way to infinity. Now, for every number I kick out, I have to have a union, okay? And they have to go in order from left to right, okay? All right, y'all. So y'all ready to do a problem dealing with this? Okay, so let me get my paper ready. All right, y'all. So for this example, now they're going to turn it up a little bit on these, but on these examples, we're going to find F compose G of X and G compose F of X and the domain of each. Okay, so we got to find f of g of x, g of f of x, and then we're going to tell what our domains are for those, okay? Now, let's see what f of x is. F is x plus 11. My g of x is going to be x minus 11. So for this one, notice my functions are pretty close other than this one's being added and that one's being subtracted. So first, let's find f composed g of x. So what you'll do, you'll find each one of these. Once we find f composed g, we'll put that answer in, and then they'll ask for the g composed f. We'll put that answer in, and then they'll do the domains. So y'all, f composed g of x. So remember, that means we're going to take this g function now and put into the f. So we're finding f of a g of x. Okay. So what we want to do is take our f equation here, and we're going to put the g of x into that x. Okay. So we'll have g of x plus 11 when we're done. So y'all, here we go. Let's put this x minus 11 in for that x. Doing that, I will have x minus 11. So that takes care of the x, and then I got plus 11. You know, all we can do is add like terms. What you got, Nat? X. Yo, that's right? Because the negative 11 and the positive 11, those cancel. So our final answer would be x. So f of g, we're done. We'll put in the x, and then the computer is going to say, well, what is g of f of x going to equal? Well, remember, this is the opposite. This will be a g of f of x. Okay. So that means we'll take the f of x equation and put it into the g. Well, f of x is right here, x plus 11. I'm going to take that and put it into that x. So I'm going to get x plus 11 and then minus 11. So what we got? X again, right? Because y'all, the same thing. The 11 and negative 11 are going to cancel. So y'all, good job. That's just going to end up as a x. Now, y'all, they're not all going to work like this. This one's just because mine had the same numbers for both functions, and one was being added and one was being subtracted. Y'all's will be similar too. I think the only thing they changed on this one is the numbers for y'all. All right, so now we're going to find a domain. So the first domain is the domain of f compose g of x. So y'all, here is the question. We're looking for the domain of the F composed G of X we wrote right here. Do y'all think I have any numbers I need to exclude from this function? So y'all remember, what's the only thing we were worried about on our domains? Yeah, Jackson, good job, because we have no fractions. Good job, y'all. If we don't have a fraction, our domain is all real numbers. Now remember, we're writing them in interval notation. So for our domain on this one, all real numbers is going to be negative infinity to positive infinity. Okay. So MATLAB will give you the infinity symbols when you click on the answer blank on that bar on the bottom. Okay. All right, y'all. What about our domain for G compose f of x? So here's G. So Jackson, same thing. Good job. Um, X plus 11 minus 11, y'all. There's no fractions again. So that's going to give us what? A negative infinity to our positive infinity. They also don't worry, they'll get we're about to use the union on oh, let me see. Not my next problem, but the last problem we will definitely be using the union, okay? I think these first two we didn't have anything that we had to exclude. But on that third one, you're going to see a lot of fractions, okay? All right, y'all, let's see here. On this one, same thing. They're giving us, on this one, f of x is going to equal x plus 3. G of x is going to equal, uh-oh, y'all, look at this, 2x squared minus 5x minus 3. So y'all, they are definitely turning up the heat when you see these x squareds on here. So first, it looks like we got to find f compose G of x. So that's f of G of x. So I'm going to take this f equation and I'm going to put this entire G of x in for that x. So putting in G of x for that x, I'll have my 2x squared minus 5x minus 3. And then that puts in for the x, and then I still have a plus 3. And y'all, guess what? There's only one thing I can do to that. And that's add that little bit of like terms. So what are y'all getting? A 2x squared minus 5x? Good job, because y'all look here. Those like terms cancel. And good job, we're left with our 2x squared minus 5x. All right, so that would be our first answer. Then we would come and find G of f of x. So that'll be G of f of x. Oh, look here. G has two x's on it, y'all. So since G has two x's, I'm going to take this x plus 3 and put it in for both of those x's, okay? So we're going to have 2 times x plus 3 squared minus 5 times x plus 3 and then minus our 3. So we got 2x minus 5x minus 3. It's just our x happens to be that whole function. So y'all, here is where I get one of the biggest mistakes in mathematics. Is this right here. This has got priority because it's got the exponent. But y'all listen, x plus 3 squared does not equal x squared plus 9. Okay? That's where I get the biggest mistakes. People square both of these and they bring that down as their answer. I'm going to go on the side right here and we're going to figure out what x plus 3 squared equals. Okay? So let's work it on the side and then we'll bring it over here and put it in the line. Because once I square this, we'll put it here behind that too, okay? So y'all, x plus 3 squared. You're not going to distribute to exponent because this stuff is being added. So since it's being added, you're going to write it twice. Okay, so you got to write this twice. And what you got, Jackson? Definitely, we got to foil this. Good job. So y'all, we would have to foil this. So remember, anytime stuff is being added or subtracted inside parentheses and they're squared, bring it over to the side and foil it, okay? So you'll do your x times x is x squared. X times 3 is 3x. Then on the inside, 3 times x is 3x. And then 3 times 3 gives us a 9. And y'all notice when you foil, you got like terms in the middle. So you're going to come down with your x squared. What's that? 3 and 3 is giving me the 6x. Oh, you were starting out right up there, kid. Yeah, you were starting out right. So remember this 6 had an x on it and then bring down that plus 9. So y'all, this is what x plus 3 squared equals. So we're going to put in x squared plus 6x plus 9. And I'm just going to bring this all down. Minus 5 times x plus 3. And then minus my 3. So here's the fun part. Now I got to get rid of parentheses. So to get rid of the first parentheses, we're going to distribute that 2 through there. And then on the second parentheses, we'll distribute a -5. So remember, this is some more of that support homework from the other day. So here we go. 2 times x squared is 2x squared. 2 times 6x is 12x. 2 times 9 is 18. -5 times x is -5x. -5 times 3 is -15. And then at the end is my -3. So y'all, let's see, let's get these like terms added. The x squared is the only x squared here, so we're bringing down our 2x squared. But the x's will add. So y'all, we got 12x minus 5x. What's that, 7x? And then all three of these numbers will add together. Oh, y'all look at that. 18 minus 15 is 3. 3 minus 3, look at that, that's 0. So the numbers cancel out. And our final answer, good job. So yeah, you got the 7x in the middle and then the 0. So guess what? Final answer. Y'all, so let's see. First, how about the domain of my f composed g of x? So here's your f of g of x. And when we plugged it in, we had this. So my question is, what's the domain? So no fractions again, good job. So that's going to be -infinity to r positive infinity. Well, y'all think about this one. What about G of F? Same thing, good job. So that's going to be what? A negative infinity to a positive infinity. All right, so the one you've been waiting on, and we'll knock out this last one for this section, and then I'll let y'all take a break. Okay? Because you know they're not going to tell you about interval notation without giving you a problem with fractions, okay? Now, I will say on this one, it's really, really tricky trying to simplify these, okay? So let's see what we got. F of x. F of x is going to be 2 divided by 1 minus 9x. G of x is going to equal 1 over x. So y'all not only one, but two fractions on this one. So look here. First of all, we're going to find f composed g of x. So we said that would be f of g of x. So we're going to take the f function and put this g in for that x. So that'll give me a 2 divided by 1 minus 9 times my x, which is 1 over x. Okay, now, later on when we think about our domain, what number can this not be? Because at this point right here, there's a number. Okay, good job. It cannot be 0 at this point. So remember, when we do our domain, at this point, we know x cannot equal a 0 at the moment, okay? Now, y'all, let me show you how you would simplify this. The first thing I would do is multiply this fraction times the 9. So your 2 will stay on top. And I have my 1 minus. So y'all, when you multiply a whole number times a fraction, the whole number multiplies times the top. So I would do the 9 times 1 and get a 9 on top. Because we treat the bottom like it's a 1. Any number that don't have a number under it has a 1 under it. So 1 times x will give me my x. So let me tell you now. Now what's happening to us? We cannot leave a fraction with a fraction in the denominator or numerator. So you cannot keep fractions inside of fractions. These are called complex fractions, and we need to simplify this until it looks like either like this or the other one, okay? Y'all, let me let one in real quick. All right, so since we don't want this fraction to be here, we're going to try to get rid of this denominator. So to get rid of the denominator, we're going to multiply all three parts of this fraction by that x. So multiply all parts by x. So if I can do that, that's going to get rid of these fractions. So y'all, I would come over here and multiply 2 times x on the top. I would multiply the 1 times x on the bottom. And then I would multiply the 9 divided by x. So every single part of this has to get multiplied by the x. Because remember, in a fraction, what you do to the bottom, you got to do to the top. And then when you multiply, it distributes over, okay? So y'all, let's see what we got. 2 times x is what, 2x? On the bottom, 1 times x is x. And that's going to be minus. But y'all look at this. These x's cancel out now. And good job, all that's left is my 9. All right, let me ask y'all this. So Katerin, let's see if y'all can get this. What number can this x not equal? Well, it can't equal 0 in the bottom, so good job. It cannot equal a 9. Good job. So at this point, we know that the x cannot equal 9. Okay? So we'll use those in a little bit with our domain for this one. And looks like I got 2 numbers. So y'all guess what? We'll have 2 unions on that one, okay? All righty now, let me see here. Now we got to do what? G compose f of x. So that'll be a g of f of x. All right, y'all. So we take the g function and we're going to put this f of x in for that x. So that'll give us 1 divided by 2 over 1 minus 9x. So y'all, this is like my main fraction line here. Okay, that fraction line there. So this is like a 1 on top and a fraction on the bottom. So remember, at this point, we need to figure out what that x cannot equal for our domain in a little bit. Okay. But let's simplify this one first, and then I'll show you the 2 places you got to worry about. So remember up here, since this denominator was the x, I multiplied top and bottom by the x. So what I'm going to do here, since this bottom is a 1 minus 9x, I'm going to multiply top and bottom by 1 minus 9x. Okay. So on top, I'll have my 1 times 1 minus 9x. On bottom, my 2 over 1 minus 9x will also be multiplied by 1 minus 9x. All right, y'all, so look, on the top, all we got is a little multiplying. So we'll have a 1 minus 9x. But y'all look at this on the bottom. The 1 minus 9x is cancel, and all that's left is a 2. Let me see what you got there. You got 1 minus 9x. Good job. Good job. Perfect. But y'all look at this. Do we have to exclude any numbers from this fraction right here? So how about this? Is there any way that you can turn that 2 into a 0? Because there's not even a variable down here, right? So since we can't turn this 2 into the 0, we don't have to exclude anything on this part. So all we got to worry about excluding is this little part right here in a little bit, okay? All righty, so let's do the domain first of R f of g of x. Now, they're still going to start at negative infinity, okay? But on this f composed g, we said right here, x could not be 0. And then when we got to our final answer here, we said this x could not equal 9. Now we got to go in order left to right. So the first number we're going to hit would be 0. So we're going to union around that 0. So notice I'm going from negative infinity. I can almost get to the zero, but I can't equal it. Now I'm going on the right side of zero. From the right side of zero, we're going through the numbers until we hit that 9. So since we can't equal 9, we're going to union around our 9. So y'all notice I got one union around a 0. I got one union around a 9. From that 9, I'm headed off towards positive infinity. So y'all, this is sweet because this is now how I can write this instead of saying x such that x is a real number and x cannot equal 0 and x cannot equal 9. So this union is a pretty quick way of saying all that, okay? All right, so now the domain of our G composed f of x. So that was right here. So we said the only part we worried about was right here. So remember what you would do, you would set 1 minus 9x equal to 0, and y'all would actually solve that, okay? So solving this, I'm going to subtract 1. I get negative 9x equals negative 1, and then divide by negative 9. And y'all, I get what? X is equal to a 1/9, which means, good job, we cannot equal 1/9, so we're going to union around that 1/9. So once again, you're going to start at negative infinity till we hit our 1/9. Union around that 1/9. And from 1/9, we hit positive infinity. So y'all, we'll get a lot of practice using this interval notation as we go through the year. But y'all, that is 9.1, composition of functions, okay? So y'all, what I'm gonna do, I'm gonna pause the recording, and I'll leave this up here if y'all are catching up. What is it, 10:54? Let's take a break till 11:05, and at 11:05, we'll come in and we'll knock out our 9.2. So, any questions? Oh, y'all, I'm not seeing anything, so let's take a 10-minute break, and I'll see y'all in a little bit. Well, y'all ready? All right, y'all, showing 11:05. So I'm gonna get us recording and we're gonna get into 9.2, which deals with inverse functions. All right, y'all, so here we go, 9.2. And this is inverse functions. So remember, inverses are sort of like the opposite of a function, okay? So y'all hang on just a second. Let me get my notes back up here. All right, so they start out on these examples wanting us to find the inverse of a relation. Remember, a relation is just a relationship between a domain and a range. So we're going to find the inverse of the relation. So y'all, the relation set they're giving us is a set of ordered pairs. So I got the first point is -9, 2. Then I have 6, -6, -5, 9, and then 5, -5. So they're giving me a set of ordered pairs, and they want us to find the inverse. So to find the inverse of this relationship, we simply switch each x and y value. Okay, so here's our answer. Now, MATLAB will give you the curvy parentheses, but when you put your points, you got to put all these commas too, okay? So for the first point, remember this is the x and that's the y when you're in ordered pairs. That's all the x's and y's. So we're just going to switch them so that we get a 2, -9. All right, switching the next one, you would get a -6, 6. A 9, -5. And then finally, a -5, 5. And then be done. So like I said, MATLAB will give you the curvy parentheses. All you're doing is coming in and switching the x and y values, okay? Same thing on the second one, but they're giving us an equation to do it with. So we're going to actually find an equation of the inverse relation. All right, y'all, they're giving us x to the third y equals -3. So remember, what did I do to these points? I switched the x and the y. So our answer for this one, all we're going to do is switch the x and the y, but we're not going to move the exponent. It stays there. All we do is change the actual variable. So if we change the x and the y, our answer will be a y cubed x equals -3. So we get a y cubed x equals or -3. So the main point you want to get out of this is that when we find the inverse of something, we're simply switching out the x and y variables, okay? Now, before we get into doing this with a function, we're going to learn about what we call the horizontal line test. Remember, we did vertical lines up and down when we looked for functions. This horizontal line tells me whether a function is what we call one-to-one. And what that means is that all the y values can only have one x value. Sort of the opposite of my function, remember. For the function, the x's can only have one y. Okay? For the inverse function, the y's can only have one x. So to determine if something is one-to-one, we use the horizontal line test. Okay? So if a horizontal line can intersect a graph more than once, the graph is not one-to-one. And y'all remember, one-to-one means that all the x values, it means that all the y values can have one and only one x value. Okay? All right, so for the first, looks like 3, 4. So for 3, 4, 5, and 6, they're just going to give you some graphs. So I'm just going to draw some graphs, and y'all are going to determine if they're one-to-one. So we're using, whoops, using the horizontal line test. Determine if it's one-to-one. Hey, also, let me just draw some pictures here. So for number 3, here we go. Got my X and Y axis. And this graph sort of curves upwards to the right. Now this should be more flat right in here. But I need to determine if it's one-to-one. So I'm going to put me some horizontal lines on it. Notice it only intersects it once there, only intersects it once there, only intersects it once there. Anywhere I put this horizontal line, it's only intersecting that graph once. So this would be, yes, one-to-one. All right, y'all, let me draw another one here. And this one will be on y'all. Oh, what about a upside down parabola? Y'all, is this function one-to-one? So what do y'all think? Oh, y'all are hitting that one hard. Good job. That is definitely a no on that one. Okay, because remember, That vertical line would hit it twice when you drew it across there. So y'all, you'll have a couple problems just doing that on this stuff, okay? Determining if there's four of them, like I said, and you'll determine whether they're one-to-one or not. The big thing we want to get into is what's coming up next, okay? So, because what we want to do is we're going to be finding the inverse of a function. And y'all, inverse notation will be f-1 of x. So f of x was function notation. f-1 of x, this is inverse function notation. Now, here's the thing. The function has to be one-to-one. So if you were to graph it on your calculator, you would see that it would be one-to-one or not, okay? So here's the thing. On the homework, from 7 through the rest of these, every single one of them is going to be one-to-one. So part A, they'll ask you, is it one-to-one? Put yes on all of these, okay? But if you wanted to, you could graph them on your calculator and you could see that they're actually one-to-one. So I might graph one or two just to show you. But that's the thing on these, okay? So let's look at the steps. So the first step, because these are going to be f of x equals something. So the first step, remember, I told you the other day that f and x and y were basically the same thing. So the first thing we'll do, we will replace the f of x with a y. So instead of f of x equals something like 3x plus 2, I now have y equals 3x plus 2. So now that I got a y there instead of the f of x, y'all remember what we did a while ago when we found the inverses? I switched the x and y variables, right? So that's what we're going to do here. We're going to switch the x and y variable. Now, since we've got that x and y switched, we will now solve the equation for the y. So we're going to solve for y. Once I solve for y, I'm pretty much done. But now I'm going to replace the y with this f-1 of x notation since it's the inverse function, okay? So I will replace the y with f-1 of x. Okay, so, and then I'll put a little star down here that says to have an inverse a function must be one-to-one. But y'all don't worry, like I said on the homework, they're all going to be one-to-one, okay? That's the steps. I'm going to follow every time. So for these assignments, they want me to, for the following function, part A, determine if it's 1-to-1. And then B, if 1-to-1, find its inverse. Okay. So for number 7, they're giving me f of x equals x minus 6. Now, I will show you this on my calculator. So I'm gonna go to y equals and put in x minus 6 on our calculator, okay? So let's see. All right, so that was from a while ago. So I'm gonna go to y equals, and we had what, x minus 6. I'm gonna graph that. And you'll notice this is just gonna be a straight line. But if I intersect this thing with horizontal lines, it's never going to intersect it more than one time, okay? So we definitely 1-to-1. So since it's yes 1-to-1, we would put yes, and then we're going to find that inverse. So remember, first thing I said up here, replace the f of x with a y. So I'm going to replace f of x with a y. Then I said I'm going to switch the x and y. So I'm going to write my steps over here. So I replace f of x with a y. At this point, I'm going to switch the x and y so that I get x equals y minus 6. All right, so we got the x and y switched. Now at this point, we need to solve for the y. We got one step to solve that for the y. All we're going to do is add a 6 to both sides. So I get my x plus 6. That's going to equal my y, and then them 6's cancel out on that side. So this is now my inverse function. So my last step, replace the y with the inverse notation. So I'm just going to put my inverse notation on the left side, and that's going to equal my x plus 6. Now, if you notice, inverse functions have opposite things going on. This one had the 6 being subtracted. This one has the 6 being added. So you'll see if you was to graph that x plus 6, instead of it going um, up at that -6, it would be up here at +6 doing that, okay? Alrighty, so questions on that? That's the trick on these. Replacing f of x with y, switching them, and then solving it for the y, okay? Hey, also, let's try some more of these. So this would be number 8. They're giving us f of x equals 7x minus 9. All right, so I would say if you graph this, it's another straight line going uphill to the right, but it would definitely be 1-to-1. So we're going to find its inverse. We're going to replace f of x with a y. All right, y'all, guess what we're going to do next? We're going to switch that x and y around so that we get x equals 7y minus 9. And y'all, let's see, we're going to solve it for the y now. So we're going to move the 9 over by adding. So y'all look here, we get an x plus 9 over here. That's going to equal to 7y. And then them 9s cancel that over there. So now we got to divide by 7. And remember, everybody gets divided by 7. So the easiest thing to do on the left side is just to put this whole thing over a 7. And that'll equal to 7y divided by 7. So we cannot do nothing here. So that's going to stay x plus 9 over 7. But here, 7 divided by 7 makes that a 1y. So then you'll come down in your F inverse notation, and your answer would be x plus 9 over 7. So look at the opposites. The 9 was being subtracted, it's being added, it was being multiplied by 7, it's being divided by the 7, okay? So in Math Lab, we would put that answer right there. All right, y'all, any questions on these yet? All righty, so let's go to 9. This is probably the trickiest one. F of x equals 8 over x plus 1. So I think this is one of the trickier ones, but here we go. We're going to replace the f of x with a y. So we'll get y equals 8 over x plus 1. All right, y'all, so let's think. What's my next step on this? So we're going to switch them. Good job. So that'll give me x equals 8 over y plus 1. So here's the thing. I need to solve this for the y, but I can't solve it while that y is sitting down here in the bottom of this fraction. So you remember a while ago when we did that composition and I wanted to get rid of the fraction? I multiplied both sides by that denominator. So what I'm going to do, I'm going to multiply both sides by that denominator. So that's the easiest way to get rid of fractions. And what that does is that's bringing the y up here instead of keeping it down here. Because these things are now going to cancel out. So I get my y plus 1 times x equal to an 8. Now, y'all, here's what I want to do. I don't really want to distribute this stuff. I'm not going to multiply this stuff times x because I'm actually solving it for the y in here. So instead of distributing that x, I'm going to divide by x to get rid of it over here. So I'm going to take this y plus 1 times x, and I'm going to divide by x, which means this 8, I'm going to divide by the x. So y'all look here what happens. X's are canceling. So all we got left over here is a y plus 1, and we don't even need to keep that in parentheses anymore. Now over here we can't do nothing, so that's just going to be 8 over x. So y'all see this, that's one of my favorite moves to get rid of the fractions is multiply both sides by these denominators, okay? Now at this point, I got one more move to get that y by itself, and that's to take care of that plus one. So we're going to actually subtract one from both sides. So over here, all that's left is a y. And y'all look at that. These are not like terms. So I'm just going to make that an 8x minus my 1. I'll be careful when you punch this one in Math Lab. You can't put the -1 up here with the 8 all divided by x. The only thing that can be over that x is that 8, okay? Now, replace that with our inverse notation. And our final answer would be the 8 over x minus 1. You know, fractions are always sort of tricky to work. But the whole reason I did this step was because I couldn't solve it while that y was down here. We had to get that y brought up to the top, okay? All right, y'all, looks like we're moving on to number 10. So there's only 12 of these, okay? So let's look at 10. On 10, they're giving me f of x equals x to the third minus 4. Yeah, we're going to do the same thing. We're going to replace the f of x with a y. So y equals x to the third minus 4. I'm then going to switch that x and y around so that I get x equals y to the third minus 4. So y'all, if you notice, we're doing the same thing every time. The only difference on these problems is actually solving it for the y. So let me tell you, you got a y cubed here. What we want to do is get this y cubed all by itself. So we're going to add 4 to both sides. So I get an x plus 4 over here. That's going to equal my y to the third. So I wonder what undoes these exponents. How can I turn a y to the third power into a y? So that would be the question of the day. So y'all, I'm going to recall y'all on something. The way to turn these exponents into just that variable is by taking square roots, cube roots, or whatever roots. So the nth root of a to the n equals a. So whatever the exponent is, that's the root you got to take. If it's a 3, we take a cube root. Exactly. If it's a 4, we would take a fourth root. A 2, I would take a square root, okay? So we're going to take looks like you got a cube root of x plus 4. Good job. We're going to take the cube root of both sides. So, y'all, we can not do nothing to that. So that's going to stay a cube root x plus 4. But here, this cube root cancels with that exponent, leaving me a y. All right, y'all, the last step, replace the y with our inverse notation. And that's going to equal a cube root of x plus 4. So when you punch this answer in, MathLab will have a little radical, and it'll have like a blue box there. Pick this one, that way you can put in that 3, okay? All right, remember, exponents are undone by radicals, okay? Oh, y'all, how about this one? They're giving us f of x equals 2x squared plus 3. Now, out to the side, they're saying x has to be greater than or equal to 0. The reason they're saying this, because if you was to graph this, if we were to graph that, and all the x's were here, it would look like a parabola. Well, this parabola wouldn't be 1 to 1, right? But guess what? They're telling us right here that the x's are only the x's that are greater than or equal to 0. Well, the x's greater than or equal to 0 are on the right side. So they're not wanting us to count this side of the graph. So since x has to be greater than or equal to 0, this wouldn't be here, and we would only consider that part of the graph that is. That's how they can make it 1 to 1 by restricting the domain. So right here, they're restricting the domain. That way it is actually 1 to 1 if you look at that right side, okay? So like I said, they're all going to be 1 to 1, and the ones that ain't, they're going to restrict it, okay? So y'all, since we know it's 1 to 1, we're going to replace the f of x with a y. So y equals 2x squared plus 3. Right, y'all, it's that time, right? We're going to switch our x and y. So x will equal 2y squared plus 3. So y'all, we need to solve this for the y. And it looks like we got a lot of work on this one because we got to move the 3. So we're going to do what? Subtract 3 from both sides. So here we go. We get x minus 3 over here. That's going to equal 2y squared. Now I need to do one more move before I mess with that y squared. I don't want that 2 to be in front of that. So since we don't want that 2 there, we're going to divide both sides by 2. So we'll have an x minus 3 over 2 will equal our 2y squared over 2. So y'all, what's that doing? We can't do nothing over here right now. But over here, the 2's cancel, and I'm left with a y squared. So here's the question. How can you turn a y squared into just a y? Let me see what y'all got. Y'all got square root, x minus 3 over 2. Good job. So I'm going to do square roots of both sides. Y'all, we can't do nothing with that. So that's going to stay a square root of x minus 3 over 2. But the square root of y squared is a y. And y'all, my last step, put it in inverse notation. Now, MathLab will give you this f negative 1 of x. All you're actually doing is putting in your answer, which was our square root x minus 3 over 2. So this one, you would hit the regular radical, then hit the fraction, and then put in your x minus 3 on top, and then your 2 on the bottom. Okay? So notice, cubes inverses cube roots. Squares inverses square roots. So y'all, we got one more to go in this section, and that would be our number 12. So I'm going to let y'all have just a second to Write that. All right, so when I say number 12 coming up. All right, y'all, you got an f of x equals square root of x plus 4. So y'all, lead me through this. What's your first step? All right, so I'm going to replace the y. Good job. So I got y equals square root x plus 4. All right, next step. So y'all have to work this one all the way out for me. All right, so I'm going to switch. So that's going to give me x equals square root y plus 4. So let me ask y'all this. What can y'all do to this thing next? Because I don't like that radical sitting there. So how can I get rid of a radical? So let me ask y'all this. What's the opposite of a square root? All right, so let me recall y'all. Square it. There you go. So let me recall y'all on this one here. So when we start with something like a square root of a, the way we get rid of their radicals is squaring each side. So no matter what the index here, if you're under a radical, then I would raise it to the exponent that matches that radical. So we're going to square both sides. So that'll give me x squared equals square root of y plus 4 squared. So y'all, the x can't happen, nothing happen, so that's x squared. But this radical now cancels with that exponent, leaving a y plus 4. Y'all got one more step. Well, two technically. All right, so what you going to do to solve that? All right, good job, y'all. We're going to subtract that 4. So it looks like I get an x squared minus 4 equal to my y. And good job. And then y'all, my last step would be to put it in f inverse of x equals r x squared minus 4. All right, y'all, let me check out one thing real quick online real quick while y'all writing that down. I need to go into our course real quick and see something. All righty, so. So let me ask y'all, any questions on this? All right, so you do have a 9.1 support for this stuff. But 9.1 support was more for the composition of functions. So this is just examples helping you find function values, okay? So I'll sort of show you what one of these, there's only two problems. So for number one, they're given f of x equals x plus 15. They want us to find f of 0, f of a negative 11, f of a 13, and f of a x plus 9. And this stuff was for 9.1 support was just really to get you ready for doing all that substituting we did in 9.1 on the compositions, okay? So let's just work these four out to get you more practice. So first we're going to find f of 0. So y'all, f of 0 means I take that function and put a 0 in for the x. So I get 0 plus 15, which is 15. Then I got f of negative 11. Same thing, I'm going to put negative 11 in for the x. So I got negative 11 plus 15. And y'all, let's see, negative 11 plus 15 is what, a positive 4. So tell me what y'all would do. What's the answer for f of 13? So let's see, y'all getting 28. So let's see, f of 13. Good job. Put a 13 in for the x so that we get 28. Well, how about this one? F of x plus 9. See what y'all get for a f of a x plus 9. Well, Nat, you're quick over there, girl. Let me see. Oh, you look pretty good on that, and good job. Because we took the x plus 9, put it in for the x. So we get x plus 9, and then we still got a plus 15. So let's see, Jackson got it too, right? X plus 24. Good job, y'all, because 9 and 15 is 24. So y'all, support will have two problems doing this. And like I said, it was just to get you ready for doing the 9.1 college algebra. 9.2, we did our inverses. And y'all, that was pretty much it for today. So 9.1, we did our composition of functions. We learned about interval notation. 9.2, we did inverse functions, and we learned about one-to-one. Okay, so y'all, any questions on that? I'm going to stop my share then so I can get this ready to send y'all later. So y'all got anything bugging you from this week at all? Now, y'all, here's the thing. Tomorrow is what, Friday? So we're going to do 3.5 tomorrow, and it deals with systems of equations. Now, I'll do a few of these by hand, but I'm going to show y'all how to do these on that TI-84 calculator. So you want to get you a TI-84 calculator. Now, any of y'all that don't have a TI-84 calculator, so all y'all got a calculator, or I was going to say, if you don't have the actual calculator, you can use the I'm going to show you an app I got. Let me zoom that in just a little. So y'all, there's an app on your iPhones you can get called Calculate 84. When you download that Calculate 84, look, it looks exactly like my TI-84, okay? So if you can't afford you a handheld calculator, or you don't want to spend $150 on one, this is a free app, and it will do everything I'm doing on my calculator, okay? It's got the graph, and you can go to graph and all that fun stuff, okay? All right, y'all, let me see my chat lighting up. Okay, so yeah, so bring them tomorrow, and then oh, I need to see who is Open H. Raven, okay, okay. I couldn't remember that, so let me get that real quick. Raven, okay. All right, I got you. So yeah, y'all bring that tomorrow, and like I said, we will use the matrix features of this to help us solve those equations. And I'll be using my own screen calculator to show you all the steps that I'm pushing. Um, but I really love using matrices, and you're going to see tomorrow how nice and convenient they are, okay? All right, y'all. So I don't think I'm seeing any questions anywhere. No. So y'all, if y'all don't have any questions at all, then I will see y'all tomorrow at 10 o'clock. Um, Support lab is only to go over any homework questions you have. So if you were good on homework, then you don't have to do a support lab. So it's not mainly being taught anything. That's why I sort of showed y'all that 9.1 support. Um, so were there any questions you did have? All righty, y'all. So I guess I'll see y'all tomorrow at 10 then. Y'all have a good one, and I'll see y'all.